I want to basically discuss a new idea I had, which is like inspired by some other things, but basically it has generated through time. There's been new libraries such as Tapir or code generation such as Smithy, which basically say like, let's take a web service or some RPC service and just represent it as a data structure so that we can abstract over that thing. So I've looked at how people are doing this, and I think it could be done in a simpler way that is more beginner-friendly and readable. So I'll talk about that. And the way I'm going to do it is through type class derivation, which is a feature in Scala 3, and there were some macro libraries in Scala 2 that do the same thing, but I'll be focusing on the Scala 3 implementation. And then I'll introduce my new mechanism to do this, which is an extension to the derivation mirror framework, which is to describe operations instead of data structures. So, and then I'll compare it to the aforementioned Smithy and the other one, Tapir. Yes, so I work at the Scala Center, and we are a sort of, we're the non-profit organization that is like a sandwich in between the open source ecosystem and communicating with the research at EPFL with Martin's laboratory, and basically the liaison with the actors in the industry, such as these companies all use Scala. Yeah, we have a booth, and here's all of our people who we work with. And yeah, we're basically not-for-profit. We're supported by donations. And our main priorities at the Scala Center are to guide and support the Scala community, to coordinate and develop tools and libraries, basically making everything faster and more easier to use. And yeah, we focus on things that try and benefit all of the Scala community. And of course, we provide a lot of free educational materials, such as the courses on Coursera. And if you want to find out what we do, we sort of made an interactive talk of our roadmap last year at the Scala Days in Madrid, and you can find that video here. But you can also come to our booth and talk to us about what we're doing. And we're also looking to fundraise a bit, so please talk to us. So, on to the main topic. What are we going to do here today? So on the screen here is basically my ideal scenario, which is going to be shown in a live demo later. Let's say you want to describe some HTTP service, and we have two endpoints, basically with the same URL, which is /greet/some name, and we want to be able to greet the user with some name, with the greet method, and with the set greeting endpoint, then we're going to update the greeting that the server will provide to that same user. And we have an annotation at the top here, fail, which means that ideally each of these endpoints can fail with some model which we call the HTTP error. And I've highlighted this thing up here because what I want to derive from this definition is this HTTP service. What is that? It's basically a data structure that reifies all these operations as endpoints that we can then interpret either to make a server or a client, all from this one source of truth. And I want to also use the same model to, for example, represent the language server protocol, which is based on JSON RPC, and is a bit similar. You basically send JSON messages with some sort of method declaration which tells which endpoint should be invoking those arguments. But basically, like, I want to reuse the same model to also allow you to derive JSON RPC, for example. So why are we doing that? Basically, the whole point is to have a very simple, intuitive description of the service, like, oh, we just have some inputs with ordinary Scala types and ordinary return type. It's direct style. There's no description of effects, because the whole point is that when you derive something, then that thing can then add the effects on later or manipulate the types in however way it needs in order to service the user. yeah, so you get effect polymorphism basically out the box for free. It's all just depending on which things you plug in to interpret that service. So what is the mechanism that we're going to use to do this thing? It's type class derivation. And that's basically a built-in feature of Scala 3, which basically allows you to extend a type with new functionality, even if you don't control that type. But we'll be focusing on when you do define the type yourself. And the idea is that you get this new functionality by analyzing the structure of the type in a generic way. So for example, let's say we have trait codec, and it has an extension method that gives the capability to convert some value x of type t into JSON. So if you have an instance of that codec, then basically you're giving evidence that t can in fact be serialized to JSON. And type class derivation is the mechanism where we provide that automatically, so you don't need to implement it yourself, which basically is improving the productivity of the developer. So I'll give you an example how it looks in code and what happens. So let's say you declare case class foo with an x parameter of type int. You say it derives to codec. And then the compiler desugars this into providing a given instance of codec for foo by calling this method codec derived. And basically, what this means is that any point you have some foo, you could call dot to JSON, and it should just work. But how do we provide this codec derived method and implement it in a way that you don't really need to know beforehand what foo is or what list is or any other type of argument you might call this for? So yeah, let's have a look at what it might look like. Typically in Scala 3, what you would do is you declare this method in the companion object of codec called derived, and you want a type parameter t to signal that it accepts any type at all. But when we have any type at all, we don't know anything about that type, so we need to constrain it somehow so that we can learn something about what is inside t. And that's why we use this thing mirror. It's provided by the standard library. So you just say using mirror of t, and basically mirror is a thing that will be supplied automatically by the compiler, and it gives you some rich information about the structure of the type. So what is one of these mirrors? So let's say we have an enum I list. So it's like the linked list, but specialized for integers. So it's an enum with two cases. We have well, I'll describe how it is here. Basically, if you see this list structure, you know that at any point in time, it can only be one of two shapes. It's either going to be icons, which is a record with a constructor with exactly two arguments. We have x of type int and xs of type ilist. Or we have the other case, inil, which is just a singleton value. And the point that I rigidly laid out these bullet points is because that's exactly what the mirror tells you. So if you got a mirror for ilist by summoning Scala deriving mirror.of and ilist, you're going to get a value which includes some of these member types. So you see that, oh, the mirror type is ilist, and oh, it has some element types, and these mean the cases of the ilist enum. Those are going to be icons and inil. And then you also get the labels of the types as well. So that's basically the names that they were declared in the source code. And why are these separated is because, for example, if you want to serialize some tag or information to differentiate in JSON or some data structure that needs to differentiate between things, you can use these strings. And then if you want to further dive into the member types, then you can inspect the mirrored element types. And the point is that by being type members, they basically have zero overhead in the bytecode. They're all just a compile time construct. And we're going to use the metaprogramming features of Scala to inspect these types in the mirror. For example, if I look into the icons, then I can also summon a mirror for icons. and instead I get this mirror product. Before we had mirror sum. But now we have mirror product, and basically what it tells us is that these are the types of fields rather than the types of cases, and these are the labels of fields. So I want to introduce in this talk that was all previously, that's all part of the standard library, but I want to introduce a thing I was working on, which is a new kind of mirror, and why do we need that thing? So yeah, let's say this is a simplified version of that greeting endpoint description. So yeah, we know that through like Java reflection, often you do want to look up and reflect on methods, but this is something that the compiler, Scala compiler, doesn't really give you through mirrors. So what if we wanted to generate a mirror to describe this hello service? What would that look like? Well, if I break it down again, this is the information I want to know. It has two operations. It has greet, which has no arguments, return string. Then we have set greeting, which returns a unit, so it doesn't return anything. And it has one parameter, greeting of type string, and it has this annotation foo. These are all the informations that I want to reflect in my mirror. So yeah, I've implemented this for the demo today. But let's say, for example, you have this operation mirror, and yes, it tells you that the type that we are reflecting on is the mirror service, hello service. It doesn't have any annotations here, and it has two operations. There's greet and set greeting. And then these operations have this type that I break down here. So there's the greet operation, which doesn't have any metadata, no annotations. It doesn't have any arguments, so these are empty tuple, which is a tuple with no elements. Then we have the output type, which is string. So this is quite a simple operation. Then to show how it gets more complicated, the set greeting, we have some annotation here, which gets represented in the metadata here. And then we have one parameter greeting of type string, and we return the unit. So you have this funny encoding here where I put the foo annotation on this meta thing here and put it inside a tuple. And why do we need that? It's basically because annotations are not types. So in order to put them inside a tuple type, you need to annotate something. So I just chose this name meta because it's just a target for you to add annotations to. But the point is that through the library that I'm going to show you, this all works automatically. You just declare a dependency on this ops mirror, and you get this stuff for free. Yeah, so, and each of these foo annotations need to extend from this meta annotation, which is what the library looks for to add it into there. This allows you to do the nice thing where if we extend the meta annotation, then we can basically define a domain-specific language to describe, for example, HTTP endpoints or JSON RPC or any other protocol that you want to implement, and you're going to get it reflected in the mirror. So this brings us back to the HTTP service, which, yeah, let's just dive into some code, I guess. So yeah, let's say I have my hello service here, and I want to derive the HTTP service from here. And what is HTTP service? It's basically just a data structure that contains a map from names, which are basically those method names, to some sort of root. And a root basically is the method, which is get, post, put, and the URL. And then it describes the inputs to that root. Which are basically, yeah, they have the argument and where the argument comes from. So if I split the screen, yeah, let's say here we have the set greeting, and we have a parameter name, and name comes from the path. And what does that mean? It just means at runtime we're going to look inside the URL to extract this name. And then greeting, we have the body, which comes from here. And that means, yeah, look at the body of the request. And it's quite similar with greet. We just look in the name parameter. And then we have two other things which are important, which is that this returns unit, so you don't expect anything return. and it says string, so you want to receive some string, which means that you're actually going to have to read the response body. So this is, and I have this fail annotation here, which means that each of these endpoints can fail with some sort of integer. So if I was going to try and implement one of these servers, like what do I do here? And how much time do I have? 15 minutes, okay. So if I wanted to basically inspect the HTTP service, then because I declared derives HTTP service, then now I can just get the service here. And then if I want to inspect the routes, I can just do service routes and print those out, and let's not crash. So if I run the program here, then this is at least the reflection of the data structure that I generated from these routes. And now we can do the exciting thing, which is actually implement the server. So what do I have here? I have, let's get the endpoints, and I have this separate thing here, which is endpoints of. And what this is going to do is it also, actually I should demonstrate how I got this. So how do I get this HTTP service thing? I told you I need to call this derived method. And in order to help implement the derivation, I need to use an ops mirror. And then inside the ops mirror, like I said, it's basically just a trait with these type members. And inside, so you have the ops mirror, you have metadata, then you have the mirror type, and then the name of the thing, the operations you have, the labels. And each of these operations has input types, output type, error type, metadata, and then argument metadata on each of the inputs. So if I wanted to print this out, it would actually look kind of ugly, but maybe we can do that. Gonna just do the same thing here. Maybe I won't do that. Right, I think I'll give up on that one. Yeah, that's because I just wanted the ops mirror this way. Anyway, so I won't show you that. Yeah, so let's do the cool thing. So what is E? Basically, it's this endpoints thing, and endpoints is, again, using the ops mirror in order to provide a rich decoration over the roots, which were this thing that I showed you before. So in the HTTP service, we just have these roots, and they don't have any rich type information. But then the endpoint is adding input types, error type, and output type to these roots. So if I look at the endpoints for the hello service, I can access the greet, I can access the set greeting, and this is all inferred for you in the IDE with the help of metaprogramming. So both these endpoints have types, so I know that greet has an input of string, errors with int, and it returns string. And I know set greeting has 2 arguments, so type strings, it errors with int, and it returns unit. And if I want to do something fun, then we can do the create a server, and then we have the server builder, and then I can add my endpoint, and then get the greet, and I'll fill it in automatically. Thanks, Copilot. And the useful part about all the, and I'm going to create it with the 8080 port, and then when I shut down the program, I want to close the server. So the good thing about this is that each of these handles actually is a function that is correct to that endpoint itself. So we know that set greeting needs a function with 2 string arguments, and it should return basically an either of unit or int. And the greet only needs one argument, and these are all correctly typed by the compiler. But I want to do something actually interesting, which is store the greetings in a concurrent hash map, because who knows how many requests we're going to get. And instead of just saying hello, then we want to get the name, or else say hello. And in this one, we want to set the greetings, so set the greeting. Yeah, and then we can run this thing again. And if I go to the terminal, then we can ask the greeting. So we get curl localhost 8080 greet Jamie, and I get hello Jamie. But then I can send a post request to greet and set the body to goodbye. And when I request hello again, I've got goodbye now. So that's actually running on the app I just made now. And you can see that we received some requests here, like goodbye or body. And maybe just to check that I'm not lying, does someone want to shout out a message I put here? That's just a greeting. Like, how do I say in Polish or something? No, okay. I don't, Scalar 920, I don't know. So yeah, I'm not lying. So I don't know. That was a random, I swear. Now I want to show that I had a client as well that I can derive from the exact same thing. So just close that. So if I want to instead make a client, then I get again the endpoints, but now I want a thing called a partial request. Yeah, and then let's just do that. I think it doesn't like that because I've already got this running, so I have to run it in the terminal. So yeah, now I've made the client that is remembering the message that I just sent in the curl. So if I wanted to call the other method, see, it's amazing what AI does for you. So what's happening in these two things? Basically, greet, I know it needs one argument, so I have to pass a single string. But set greeting needs two arguments, so who will be appended to the URL, and then the new greeting is the method body. So now if I do this, I can do from the client again my new message, and then if I do a even newer message, then I should get the old message printed to me. So yeah, I am interacting with the server with a client that I just made in like 10 seconds. So obviously is inspired a lot by Tapir and STTP. So I wanted to go back to this and say, why don't we just use Tapir, for example? So the thing I showed, I actually wanted it to be a wrapper around Tapir to make an alternative if you wanted a sort of simpler way to read the APIs. But Tapir is really great. It also lets you define your endpoints as data, and you can both derive clients and servers, just as I showed now. But I think, in my opinion, it's like less immediately readable what this does. You have to sort of dig in and say, oh, okay, there's a path parameter of string and path parameter of int. But the thing is that it gives you really great ultimate control over what you do. Like, you can precisely say this is going to be JSON result. So I think is a really compact way to define things. Then there's the thing I mentioned earlier, Smithy. Smithy's like a separate programming language, but it's just specialized to generating these services. So it's good because everything's just pure data, and you get, it generates code for you, and what's good is that you can extend it to basically have whatever protocol you want. But the downside is that it is a new language. And then the final argument is like, why would I use this mirror thing and not the macro API? And the macro API is basically like, you're going to be duplicating work a lot, it's very verbose, less readable, etc. And then the final thing I want to show is just how did I implement this thing in the first place. So if I go to the macros, then I want to show how you inspect the mirror. So you have your mirror here, and this is using the quotes and splices API. So we're going to receive an expression that represents the mirror, and we want to return an expression that represents the HTTP service for that type. And basically, we can inspect the mirror by pattern matching on the expression, and we can see that we got an ops mirror, and we can extract the mirrored operations here, which is that basically the representation of the methods. And we can extract the operation labels here, which are basically the tuple of strings representing the names of the services. And basically, here I check that you don't repeat the same method twice, because we don't support overloading. And then I basically get that list of strings, and then I zip it with extracting the services from that thing, and I just put them in a list and then build the map up here. And yeah, if you extract the service, then basically again you can extract the metadata by calling my helper method, and the metadata is a list of annotations, and these annotations are basically represented as expressions, and then I filter on the annotations to say get my method type, so get post put, and then that becomes the root of the endpoint. Then if I want the input types, or the input labels actually, then I again look at the type of the operation and extract those labels. And then, yeah, what do I want to do? I extract the metadata from each of those parameters. So, for example, I'm extracting the path and body here. Yeah, and then I just collect to make sure that the metadata is a source, and that gives me the source of the label where it comes from. And then I make basically a list of those and put them inside the root. And then if you want to go really deep into how it works, you can have a look at my GitHub. I'm going to make this public. I didn't yet. So it's called ops mirror on GitHub. Maybe I can do that right now. I don't know. I'm not signed in. Okay, well. Yeah, okay, maybe I'll try and do that as soon as possible anyway. So it's here, it's on the ops mirror repo, and I invite basically people to try it out and make suggestions or say it's rubbish, I don't know. Yeah, and maybe, I'm not sure what the future is, perhaps we can, yeah, anyway, perhaps we can make it into the language, or perhaps it should be a library. So there we go, and does anyone have questions?